The first part is find the equation of the tangent to the curve at the point where x equals to a, and hence find the equation of tangent to the curve y equals to ex, which passes through the origin. Now we just deal with the first part first. The first part first, if x equals to a, what is the equation of tangent to the curve? Okay, this is sort of like a parametric equation. So if you think about it, right, this tangent here, so you say draw this curve here, okay, this is ex here. So if say x is equals to a, this will be e to the power a. Okay, so this is e to the power a. Then of course we have dy dx, which is actually ex, right? So if dy dx, x equals to a, this is ea. X equals to a, y equals to ea. So equation of tangent. I think the first one you shouldn't miss any mark here. So if you really can't do this properly, please revise. This is just y minus y1 equals to mx minus x1, equation of tangent. So y minus ea equals to ea x minus a, right? So this will just be y equals to ea x minus a plus ea. So you can just leave it as y equals to ea x minus a plus 1 if you want to. You can just leave it like that, or you can just express the expanded form is also fine. Okay, equation of tangent, the first part. This part here, what we need is actually with different a, I could actually find what is the equation of tangent by using the formula that we found. Alright, so you see with this formula here, if I were to sub in a at this juncture, this is the equation here, and then I could have like a very smooth curve like that. Okay, so it's as if like it's a parametric curve equation. Okay, now what I think about this, the second part, find the equation of tangent to the curve y equals to ex, which passes through the origin. Meaning, how should you adjust your this right such that it passes through the origin? Does this tangent pass through the origin? No, right? Then the question is, where does it touch? So it should be this equation here where it passes through the origin. But how do you solve this part here, right? So it passes through the origin, meaning you need to find the a. This is clear that a is equal to 1. So you need to find out what is your a. For the second part, for tangent passes through origin, okay, it will mean that sub x equals to 0, y equals to 0 into 1. Okay, so you essentially just sub into 1. So this will be 0 equals to ea 0 minus a plus 1, and this will just give us a equals to 1. Okay, what does a equals to 1 mean? It means that if I draw a tangent which passes through the origin here, oh, just nice. Here, my a is actually, if this tangent passes through origin, my a equals to 1. Okay, this a equals to 1. Suddenly you have everything that you can solve, right? So hence, equation of tangent will be y equals to e1x minus 1 plus 1, which is actually this equation. The equation is a equals to 1, so I sub back into 1, will be y equals to ex. This is the second answer. So I've done the second part there. So now we know that if we pass through the origin, this equation is y equals to ex. Okay, this is y equals to ex. Okay, so with this information, can you do the straight line y equal mx intersect with the curve y equals ex at 2 distinct points? Okay, can you do this part here? This is a tricky part. For the last part, right, student may think it's discriminant. They use b squared minus 4ac for this part here. Okay, can you use discriminant? Okay, if can, why, and if cannot, why not? You can't use discriminant because it's not quadratic. because it's not quadratic. Okay, don't think that because two distinct points then automatically is quadratic equation. No, it's not. It's not. Okay, now what it means is this. Now if a straight line y equals mx intersects a curve at 2 points, at two distinct points, what is y equals mx? Y equals mx is actually a line through origin, gradient, with gradient m, right? Am I right? So in other words, you are looking at this line which pivots about here. Here, it pivots about here. Now, take note, you already find the line here, with the line which pivots about, the line which passes, the tangent which passes through the origin. Now, if you want a line, look at this one, y equals to mx, right? So I'm going to, okay, here, which passes through the origin here. Now you want to find the curve here, which will cuts the C twice. So how should you go about, right? So it means that your line should be steeper than E lah, correct? Because this graph here, you have M equals to E here. Okay, the gradient is E here. Anything steeper than here, this is M bigger than E. Alright, when M equals to E, it cuts a curve once. Once would mean that it cuts once, right? But anything, if you don't want any solution, then you should be M less steep than E. The gradient here is E ma. Okay. So in other words, right, for y equals to mx to cut y equals to ex twice, M must be bigger than E. Okay, M must be bigger than E. So you just look at how you should be steeper than E. E is a line where it touches once. You want it to be steeper than E. Okay. Then the next question is, Mr. Gan, won't it only cut once like that? Okay. So meaning to say, if you put this as 100, okay, good job. Put it 100, like that, very steep, won't it only cut once like this? Yeah. You don't have to worry because exponent will always catch up with a linear graph. Exponential graph will always catch up with a linear graph. Linear graph is not as fast growing pace as the exponential graph. Okay, no matter what value you give me, right, I can be sure that the exponent graph will actually catch up with the linear graph. Is that okay? Yeah. Yeah.